Welcome to the Space Policy Show. I'm Colleen Stover with the Center for Space Policy and Strategy, part of the Aerospace Corporation. We are now in our 5th year, and I'm excited to host the next installment of our season on Going Faster, on rapid launch. This episode is also part of our How Stuff Works sub-series, kind of explainer videos. So to start off, the U.S. posture for commercial first, national security needs for faster launch, as well as the rise in competition in space, means that government is looking for ways to move faster. Basically, go at the speed of innovation. The increased demand for space launch means that spaceports and launch ranges need to keep up. So I've got with me 2 experts from the Aerospace Corporation, Kim Goodwater and Johanna Malaer, and they're going to talk us through what's involved in launching a rocket. Now, remember, if you enjoyed today's show and you want to learn more about the Center's deeper research from across the space enterprise, you can go to csps.aerospace.org. And of course, all of our shows are posted on YouTube and available by podcast. So to start off, I'm going to start with you, Johanna. Can you just introduce yourself? What part of aerospace do you support? And what are some of your background? Why did I want you here today to talk?
So my name is Johanna Malaer. Like Colleen said, I work for the Launch and Test Range System Program Office over at Vandenberg. So we work on a lot of the spaceport and infrastructure that supports the launching of rocket, our aeronautical tests, and our ballistic missile tests as well. I previously worked at Aerospace in the Network Systems Department in El Segundo. But I've been at Vandenberg for the past a little over 3 years.
Nice. Thank you. And Kim, how about you?
So I've been with Aerospace for about 3 years, but I've been in launch operations since 2008. And my area of expertise is really with launch-based integration, payload processing, and then integration between the payload and the launch vehicle.
And by payload, you mean satellite for the most part.
Satellite.
Group of satellites even.
Yes, exactly.
Right. Okay, well, thank you very much. Thank you guys for being here today. I wanted to just start off with, we're going to kind of start big and then narrow in. National security space has these buzzwords, if you will, things like rapid launch, assured access, responsive launch. And I think we've kind of settled on this tactically responsive space, which is TAC-RS. All of these things are nuanced between them, right? But they're all basically about going faster and having access. In fact, we were talking earlier about a small launch demo that Space Force did last year in 2023 with Firefly, a commercial company called Victus Nox. And according to General Salzman, the chief of space operations, it went from warehouse to operations in 1 week. And so that demo, this really, this rapid launch kind of capability. There's a follow-on mission called Victus Haze, and that's going to be with Rocket Lab, another commercial company, and they will do that rapid launch as well as a kind of rendezvous and proximity demonstration in 2025, later in 2025. So Kim, I'll start with you. Why is going faster so important?
So I think there are a number of reasons. First of all, we have kind of more players in the industry now. We've got a lot of new entrants in the last 5-10 years. So there's just a lot more opportunity for launch and getting more things up in orbit. Also, there's been a big push towards more proliferated architecture. So instead of focusing on very unique and specialized launch satellites, we're kind of focusing on smaller, cheaper, bigger architectures up in space. And the reason why is because while it's cheaper, there's many versus few, right? So it's harder to impact a system. You can't the system can recover more easily if you take one satellite out or you have one fail on launch. So resilience is another big buzzword. There's a lot more risk tolerance involved with these proliferated architectures. So all of this with your bigger satellite networks, it all means more launches. And in order to get all of those satellites on orbit, you have to figure out how to launch them more quickly.
Yeah. Did you want to add something, Johanna?
Yeah, no, I think Kim hit the big points with like this introduction, which another buzzword of the Internet of Things in space, which, is those big proliferated mesh, typically the LEO networks, designing
LEO meaning low Earth orbit.
Low Earth orbit. Designing IoT in space just means your satellites are your network infrastructure. And we design things in space with very similar considerations to the way that we design networks on the ground, where we want it quick, we want it reconfigurable a lot of times. We want it to be resilient and survivable to threats. But I think the three big things that I would say that's different when they're in space are that you have size, weight, and power requirements or constraints, your swap constraints. So that determines how much processing power you're going to get on just a single satellite. The other is that they're a lot less serviceable because they're up in space. And then the third is that they're moving very fast and oftentimes an unpredictable way. And so you necessarily need, like Kim indicated, more satellites to meet the same, resiliency, reliability, efficacy, configurability than you would need on the ground. So to get the same design, I guess, intent in space, you just need more satellites, and that just means more launches. So we have to be ready to turn those around quick.
Right.
Sorry, can I add to that? So also with these larger networks of satellites up there and kind of the philosophy that we're going to build them faster and cheaper, they may not necessarily be designed to last as long. So they need to be repopulated faster too. So they need to be replaced out there on orbit. So that also leads to more launches.
Right. Yeah, that was kind of number two that Johanna mentioned in terms of them not being serviceable. And they're not meant to be necessarily, right? I mean, the idea is to replenish them, and you can always be building, in new software or whatever. Yeah, I would actually also add the idea that there's more kind of geopolitical competition, especially with China, in terms of launching faster. I know. China has demonstrated, anti-satellite testing. There's been an increase in electronic warfare with jamming and dazzling satellites. China has also demonstrated actually grappling, where they launched a satellite that held on to another satellite, one of their own, and pulled it down into a lower orbit. And so all of these things kind of are indicative of maybe the growth of the idea of the possibility of orbital warfare. So, I think that
I think that kind of lends itself. You mentioned the TACRS program, and that's kind of the genesis behind that is how can we respond to a geopolitical event at a pace that would actually influence decisions or influence activity, because our typical integration periods wouldn't necessarily be responsive to geopolitical events.
Yeah. So we kind of started big, and we kind of understanding why going faster is becoming more necessary in that kind of worldview and technology view. And I wanted to go a little bit more narrow and actually talk about the bases. So FAA lists 9 launch sites that are vertical launch sites, and that's the ones that we know and love and get excited about. There's ones that are strictly commercial, like SpaceX's Starbase in Texas. There's the Spaceport of America in New Mexico. There's a major national security one in Alaska. There's Wallops Island in the beautiful state of Virginia, which I would encourage people to go and visit because it's very close to the shore, like they all are. But also, there's the major launch ranges for the federal government, and that would be the Eastern Range and the Western Range. And the Eastern Range being at Cape Canaveral, they listed in 2024 93 launches, which is a 35% increase over the previous year. But only a handful of those are actually national security space launches. I think the estimate is somewhere between 5 and 15 on average, and all the other ones are commercial. And then there's also the Western Range, which is Vandenberg. And they listed, I believe you guys can correct me if I'm wrong, 34 launches, around 34 launches in 2024. And those are, again, both national security and commercial launch. Vandenberg is good for those polar orbits, and it's good for sun synchronous launches because it's on the west side, right, of the country. But Johanna, I wanted to start with you. I've been to Vandenberg. You and I met there a few years ago. It's right on the central coast of California, wine country. It's absolutely beautiful. But tell us more about the base itself and what kind of, if somebody was to visit, what would they actually see there in terms of launches? It's launch site, I would say.
Yeah. So the base itself, I guess you kind of hinted. So we have all of these spaceports. You mentioned Wallops, Eastern Range and Western Range, and the increase in launch. We call ourselves the range on the East Coast and the West Coast because of our heritage as this DoD missile sort of test facility base.
Right.
But now, like you mentioned, there's this massive uptake in commercial launch support. So we are transitioning to this nomenclature. We are now joining the spaceport community because of our uptake in commercial launches. So the spaceport, Vandenberg, as well as over at the Cape and Patrick on the Eastern Range, their 2 main objectives are their service provider, essentially, to the vehicle. So their 2 big objectives are, one, public safety, ensuring public safety, and the second is providing data. And those go hand in hand because our big moment as a spaceport, even though we support tests and checkouts beforehand, is day of launch. How we provide that data is through just a mass amount of instrumentation. So if you were to come to the base, they look very different at the coasts. We're, 99,000 acres of just vast chaparral, rolling hills, and littered throughout there is our instrumentation sites. So we have radars that support area surveillance on both North Base and South Base. So you leave the bases and you cross the highway and you'll go to a different one. Along there are our launch facilities as well. Up at the top of our mountains, we have at Oak Mountain and Pillar Point, we have instrumentation sites for telemetry. We have weather balloons. So if you come, we launch weather balloons every day, not just in support of launch, but also in support of other government agencies who are interested in collecting that data. So you'll see weather balloons floating around. It looks sleepy, but if you were to focus, there's a lot of activity. I think Kim can talk a little bit more about the distinction between our different launch facilities at North Base and South Base. But our instrumentation supports both your commercial launches and your missile tech. So it's pretty uniformly scattered, and we even leverage instrumentation down at China Lake, at the Knock, instrumentation up north as well. We borrow because it's quite a big field that we're looking at when we launch a rocket that we want to surveil and track.
So let me ask you before, I would like Kim to kind of weigh in on a little bit more about the the Space Launch Complexes and what it actually looks like at Vandenberg. But when you say instrumentation, what are you talking about? You're talking about, well, the radars and the kind of those things, but also like ground stations, right? Like little buildings kind of everywhere.
So we have a bunch of instrumentation, big radars, big field mills, a lot of sensors for weather. We have a ton of sensors for weather. But we also have facilities that support those as well. So we have launch facilities over near the slicks for our launch service providers to conduct business. And our major instrumentation sites also have facilities for them to conduct business out of. So they're collecting data and they send that to the Western Range Command and Control Center, which we refer to as the ROC, day of launch, so that, your range safety guys and your area surveillance are all looking at this data and telling us we're good, we're go for launch. A lot of the processing happens on site too. So you'll see a lot of facilities around and near your big radars and radomes and weather balloon stations that almost are like an intermediary or middleman for that data. So processing is happening all around base. And then when we perform an op, it all gets synchronized in this kind of neat way, paint a picture of what the range looks like.
Yeah. So just lots of computer rooms I'm seeing.
lot of computer rooms, a lot of server rooms. Not as cool and exciting, but we have a lot.
Yeah. So Kim, can you expand a little bit more in terms of what Vandenberg looks like for somebody who is visiting there? What Johanna mentioned a slick. Why don't you start there? What is a slick?
Well, a slick is a Space Launch Complex, SLC. So we colloquially say that as slick. I guess let me back up a little bit. So we have the base is kind of divided into two pieces. So we have North Base and South Base. And in between North and South Base runs a highway. So our most active launch pads currently are on South Base. We have on South Base, we have Slick 4, which is a SpaceX pad. Slick 6, which is also a SpaceX pad that they're developing right now. And the plan is for it to have the capability to launch Falcon Hemis in addition to Falcon 9s.
Can I just mention Slick 6 is the one that was at one point going to launch the shuttle. Is that right?
That is correct. Yes. That was what it was originally designed for. It has been repurposed. It launched Deltas for a while. And now it's being repurposed again, and it is going to launch Falcons. We have Slick 3 down there as well, which is a ULA pad. Right now, they're converting the pad from an Atlas to a Vulcan pad. So that construction is in work. Then on North Base, we have Slick 2, which is a Firefly pad. And that will edge Delta pad as well. So lots of repurposing on this base. We also have some missile sites around the base, Minuteman, ground-based interceptors. So, and then some like test platforms. So there's a lot of activity, like Johanna said. We have multiple payload processing sites. And one thing to know is that payload processing is, I guess, let me state what that is. That is where you prepare a satellite for mate to the launched vehicle. And so you have to do all that preparation in these specialized facilities and then transport it out to the launch pad. So in the case of Vandenberg, you're often transporting it pretty far across the base to get to the launch vehicle.
Yeah, because it's a big base, right? Like you've got and so your payload processing facility is in one place, but the actual launch pad can be miles away. Is that right?
Yes, that's right.
Mm-hmm. And they carry them on trucks, or is there a rail system?
Trucks, yeah. Specialized transportation platforms that often accommodate like elevation changes so that your encapsulated assembly can stay level. They move pretty slowly. So there's just a lot that goes into that transport.
Interesting. And so I'm gonna pick at this a little bit more. You talked about encapsulated. So is that what happens at the processing facility? Tell us what encapsulation means and what kinds of things are important there.
At the processing facility, your satellite arrives on base. It goes to this specialized processing area that's usually a clean room, because a lot of your satellites are sensitive to contamination. And your environment is controlled, temperature, humidity. And the satellite undergoes typically, because every mission is different. So typically it undergoes some testing to make sure that it survived the transport okay, make sure it can interface with certain networks that we have at the base. So sometimes they'll transmit to our Vandenberg tracking station to make sure that it can communicate with the satellite control network before we launch it into space and we can't access it anymore. So things like that. Sometimes propellant is loaded on the spacecraft in those processing facilities. Sometimes protective covers and structures are removed, and those covers are installed to protect, contamination sensitive systems or protect things from jostling around during transport. So all of those non-flight items are removed. And if you have multiple satellites, they're integrated onto a dispenser there. And then that whole stack is mated to your launch vehicle interface there in your processing facility and encapsulated within the payload fairings. And that is basically the pointy end of the rocket. And then that whole encapsulated assembly is transported out to the launch pad to mate with your rocket.
Gotcha. Lots of mating going on.
Lots of assembly.
Right. So the satellite's built somewhere, then it's transported to your processing facility. It's encapsulated with all this stuff, and then the whole thing is transported out to the launch pad, and then it's mated again with the vehicle, right?
That's typically how it's done.
Gotcha. Johanna, did you want to add anything to this, or?
No, this is covered everything. This is payload. And then day of launch is a whole different thing for the range. But we don't help much with the payload processing, except for in the event of tests, like Kim mentioned, making sure our instrumentation is ready to support that flight up there so it can communicate with the vehicle and the payload. Right. That's kind of our role. But again, our big shining moment is day of launch. So there's a ton of work that goes in to preparing the people for that.
And so Kim's been talking about this integration process that, what I've read can take up to 2 years with all this testing, and it's got to be clean, and they got to be very careful, and more testing. But the spaceports or the launch ranges are also doing stuff this whole time. And you said, your big shiny moment is day of launch. But ranges need an entire array of different things for what they call, operations, maintenance, and sustainment, right? That that OM and S. And so can you talk a little bit about what kind of services spaceports are preparing for and, what's involved there from that perspective?
Yeah. So I think OM and S, operation, maintenance, and sustainment, is a tricky term because it changes depending on who you talk to. But I think for the sake of this, OM&S is just the operations, maintenance, and sustainment that goes towards providing our critical capabilities. So the capabilities that are needed for our launch service providers right now. And those differ based on the mission and the vehicle and the trajectory, where it's flying out of, the SLC or the Space Launch Complex. All of these are factors in what sort of capabilities they require, but also how we provide those capabilities, which is why, again, I said we have instrumentation littered throughout the range. You have different lines of sight for different vehicles, depending on where they're launching out of and where they're flying. But our number one priority is range safety. So I think backing up the fact that we're a service provider, we provide on the range or on the spaceport, we provide the launch facilities, the instrumentation to gather the data, utilities like power, water for deluge, for things like sound suppression. So all of that has to be in order well in advance to supporting a launch. We don't often try to, wing things. So all of that undergoes routine maintenance and inspections and testing with respect to the vehicle and testing without the vehicle to make sure it's all in order. And then we continuously do infrastructure upgrades, which I think that you hinted at as well.
Just picking at that a little bit in terms of those utilities you mentioned. What kinds of utilities are you actually talking about? And then that's kind of different than what might be called kind of shared commodities, right? Like the water would be a shared commodity. And
yeah, so we have shared commodities. Our instrumentation is shared as well. Day of launch, we also have security. So we provide security to help clear the hazard area, which is, again, our number one priority as the spaceport is ensuring public safety. So that's a big part of that. But in terms of infrastructure upgrades, I don't know if you want me to go into specifics of how that works or where we're spending the money on or how we charge for that.
Well, give us some example of what infrastructure upgrades are typically needed, like on a regular basis. I mean, roads. I've heard terrible stories of roads at Vandenberg.
The roads, they cave in. I mean, the base it's very, very old and it's very large. It's the third largest military base in the world. So it's massive and it's these old, just like paved over dirt roads that continuously get rerouted either in support of launch, but another big priority of the spaceport and the California Coastal Commission especially is preserving, also a nature preserve. So our roads often get rerouted, again, around protected areas as well. So recently, OMB gave both ranges, Eastern and Western, about $1.3 billion for infrastructure upgrades. And that can go towards a bunch of things. I think one of the key things that when we talk about OM&S is that we're supporting, new incoming launches at the same time of having to support our old legacy customers. So you can kind of think of this as like building the plane as we fly it. So a lot of our infrastructure upgrades need to look towards the future as well. They don't necessarily fall under modernization because they're not providing a new capability, but they definitely are new and advanced in anticipation of that future support. So one example where we're spending that 1.3 implemented between now and 2018 is over on the Eastern Range, their water treatment plant. So the ranges look very different geographically, and it's pretty marshy over on the Eastern Range. So when they support a launch and they use all that water deluge, sound suppression, they're shooting water at the base of the rocket, they're pulling that from the one and only reservoir on base. And when they do that, it runs back into the reservoir. That process kills all the bacteria in the water. And so every single time they support a launch and that runoff goes back into the reservoir, civil engineering has to come in on base and they have to reestablish healthy levels of bacteria so it doesn't kill the fish and the birds and all of the wildlife that relies on that water, and it leaks into the surrounding marshes. That takes time for civil engineering to come in, test the water, reestablish healthy levels of bacteria, and say we're good to go again. In looking towards the future, to streamline that process, they're looking at implementing this water treatment facility. It's going to help streamline that process of reestablishing healthy bacteria so that we can turn around launches quicker and not have civil engineering have to stop everything they're doing and go down to the reservoir and check the bacteria level. So that's one, I think, kind of neat way that we're using this infrastructure upgrade money.
No, that's great. Great. Kim, did you have anything to add?
So I know here at Vandenberg, several years back, we had some pretty severe wildfires. And actually, it impacted our electrical infrastructure throughout the base. And so I know that there's been a lot of effort recently across the base to upgrade our electrical systems and make them more robust. So that, I don't know if that's an area where some of this money is going, but I know there's been a lot of effort involved in that. So a lot of these maintenance items are maybe not as flashy, but they're definitely important on keeping up our launch capabilities.
Yeah, that's a good point. Now, we didn't really talk about, I know that Johanna, you had said that safety being number one. We didn't really talk about all the things that are involved when a rocket is launched, right? There's safety to the public, to people. There's maritime safety, there's air safety, there's environmental safety and protections in terms of the seals that live on the Central Coast. So I want yeah, talk just briefly talk about that, Johanna, and then Kim, just in terms of what that means.
Yeah. So there's when we talk about safety as, our number one objective, right above providing data, we're talking about public safety primarily. And a lot of, I think what I'm going to talk about too goes into, being tactically responsive but we have instrumentation systems on the ground that day of launch, our big moment, provide data to ensure safety. So we have radars littered along the coast that are saying that our air and marine traffic areas are clear. We have telemetry that's continuously reporting on the health and status of the rocket and the payload during flight, and pre-flight as well. And then we have ground-based right now. We have both ground-based flight termination systems. That's part of our range infrastructure that we're migrating away from. But that prior to launch, we also conduct a lot of safety analyses. So we define a safety corridor. So based on the trajectory of the rocket and also based on the payload that it's carrying, we define okay limits for, you're going to fly this direction. And if you get a little too off course, we need to stop you. So our ground-based flight termination systems send a signal up to the rocket to distract. So essentially blow up should it leave those corridors. And we have incredibly experienced and very stressed out operators sitting on console day of launch, just watching it bump up against that imaginary line. And should it get too close to it, we blow it up. So if anyone on YouTube wants to see an example of that, there's one called Casmalia Express where the vehicle goes in the wrong direction. So that's sort of the telemetry is giving us indicators that the vehicle is good or not, which might be another reason why we might blow it up. But it's really all about ensuring the fact that it's going to go over the ocean and not the other way over Santa Maria.
Okay. All right. Thank you. Thank you. Yeah, we don't want to go over the vineyards. Protect those vineyards. And the seals.
And the pinnipeds. Yeah, we do a bunch of environmental checks to make sure that we're not disrupting them as well.
Right, right. So
our cultural sites here on base too that are protected from our local Chumash Native American population. So there's just a lot of consideration going into activities here on the base.
Yeah, I think that's a good point. And it really brings home how different the two Eastern Range and Western Range can be. Because Western Range is, it's more rural. It's a beautiful coastline. There are certain protections that the state of California has. The Native Americans are there, actively living. And then you have, Florida coast, which is, probably it has a phenomenal amount of marine and air traffic going by that has to be, then that safety corridor has to be monitored and made safe for everyone. So very different bases here. Kim, we started off talking about how going faster was becoming more important due to geopolitical concerns or possibilities or new technology in warfare or because of the proliferated architectures that offer more resilience to our systems. It typically takes like 2 years, right? But they're doing things faster. They're demoing things that can be done faster. Integration is a long process typically. What do you think is so hard about integration? The testing is important. And how are things changing to kind of help increase our readiness so that it's a shorter timeline?
So I think the simple answer for why integration is so hard is that every mission is unique. They have unique requirements, unique structures, unique systems. They have different requirements for the launch base. So some load propellant at the launch base, some don't. Some do different kinds of testing, some are more involved testing once they arrive, some don't. Some have different interfaces with the launch vehicle, so that needs to be evaluated, analyzed. There's a lot of analysis that goes into the whole rocket satellite system to make sure that, like the satellite isn't damaged in the high vibrations it might see during launch. So when those interfaces are unique, then a lot of additional analysis needs to go into that. Some have really stringent contamination requirements or temperature, humidity requirements. So all of that needs to get worked through, and the requirements need to be made very clear. And the agreements on how those requirements need to be met need to be worked through between all of the parties involved. Our NSSL, National Security Space Launch satellites go through a really rigorous mission assurance process. So for those missions, we look at the history of, if the rocket is being reused, for example, we look at the history of that rocket, all the components of that rocket, to make sure that everything looks good before we go into launch. Because for our NSSL payloads, we have for a lot of them, we have low tolerance for mission loss. So we want to make sure everything is set before we hit the button and launch into space.
That idea of risk, right? It's about risk tolerance in terms of, you don't want to scooch through mission assurance processes, because then it's more risky that it's going to blow up on the bad way.
Yes.
But there are examples where they are finding ways to do kind of faster launch. There was recently, there's actually been some GPS replacement satellites that have been demoed to be done much quicker.
Yes, it's been really interesting. We've had 2 demonstrations recently of a rapid integration process for some GPS satellites. And I think the first one took our 2-year typical integration timeline down to like 5 months. Yeah. And our second one might have been even a little faster. But going into those, there were some kind of ground rules and assumptions. The satellites were already built. They were reflights, so the GPS integration had been known. A lot of that mission analysis had been done in the past. So there was a reduced analysis period. A lot of our launch vehicle integration hardware had been pre-built. So there were no long lead items as far as procurement or design goes. So those were some of the things that we were able to take advantage of to shorten those integration periods. For in the most recent case, a lot of the mission assurance verifications and pedigree of the rocket booster had been done previously. So we were able to take advantage of that in order to shorten or make more efficient our mission assurance process. We were able to focus on the most recent history of that rocket to get that thing on orbit faster. So we're learning ways to accelerate how we've typically done things. And take advantage of that in order to get things launched quicker.
Yeah, no, that's a great point. And that kind of speaks to almost like what one commercial company called in terms of launch, like rinse, repeat, right? That kind of getting used to the way things are done, and maybe even a kind of standardization piece, right?
Mm-hmm.
Yeah. So Johanna, if your specialty is the kind of range and the spaceports. We talked about how infrastructure is kind of falling apart, maintenance is needed, but there's also room for kind of modernization, right? That Yeah, so we've got to have that maintenance piece, but then also you can't just keep the roads, you don't want to just keep the keep the same thing and just maintain what's there, but commercial space is moving faster. They're innovating, they have new technologies, launching off of sea platforms or reusable rockets. So there's like a modernization piece as well for the Western Range. Can you kind of talk to that a little bit?
Yeah, definitely. I think just like Kim said, standardization helps reduce, I think, that turnaround time for onboarding a new user. It's helpful for us too. So a lot of our modernization objectives are aimed at sort of incentivizing standardization between users while also balancing not stifling like the pace of innovation. So when we onboard a new user, unlike the spaceport is a little unique, I think, unlike like a seaport or an airport for many reasons, but one of them is that we're working with an industry that's a little bit more unexpected, hard to foresee where they're going, a rapidly evolving industry. So we're not just flying Boeing planes out of a single airport and we just need to provide the infrastructure for that. We have new commercial entrants that come in the front gate and say, I'm going to do something that's never been done before. I'm going to land on a barge. And can you, the spaceport, figure out how to provide that? And we just have to say, yep. And so while they're doing all of that integration with the vehicle, a lot of times people come to the front gate of the range and they don't even have a vehicle built. We'll say, don't worry, we'll respond to it. We'll figure out how to provide this. So at the same time that we're doing all the operations, maintenance, sustainment that I spoke about, keeping the range running for our existing users, we have to be dynamic in the way that we respond to those new commercial users. One of the big things that we're implementing is actually a mandate put down, I think, for the past 3 generals have said that we're migrating away from that ground-based flight termination system that I mentioned to an automated flight safety system. And so the automated flight or the autonomous flight safety system, that's on board the vehicle. So it completely reduces the need for your ground-based FTS. So that vehicle is aware of its position, it's aware of the parameters of the flight safety corridor, and should it leave, it's going to blow itself up. Migrating away from ground-based FTS is a major modernization opportunity and also opportunity for us to turn around the range quicker. Because it could take up to 96 hours to configure, load all the codes for FTS for it to talk to the rocket. We have to employ and staff people at that instrumentation site to do the maintenance as well as day of launch, observe the flight trajectory. And so eliminating that increases our ability to turn around. That's probably one of the biggest inhibitors for turning around the range quick so that we can support more launches, potentially even simultaneous launches. So I would say AFSS, the Autonomous Flight Safety System introduction, is the biggest game-changing, I think, modernization initiative going on right now.
Interesting. So that's 96 hours just to load all of that code in for the kill switch, right? The self-destruct button.
It's like 40 to 96 hours. And then they have checkouts, and so that could delay as well. For every launch that you see on the launch manifest, there's a whole bunch of activities going on after or before. There's like failed attempts as well. So there's a lot more activity going on than what you see on the manifest. So FTS, the 48 to 96 hours plus delays with checkouts, that's a long time.
Yeah, interesting. So we're getting to time here. I did want to just I read recently about Vader as well, because we didn't really talk about weather in terms of throughput, but I know that you can't, obviously you can't control the weather, but there's, Florida has hurricanes, Vandenberg has, thunderstorms. fog. I don't know if fog is a big deal, but Vandenberg, it's called Vader, like as in Lord Vader, Vandenberg atmospheric detection of an electrified range. And it's they've just launched them recently, 14 electric field mills that help to detect lightning so that launch operations can be safer, and we don't have so many like unsure no goes situations, right? Like it's because they have to be very cautious. If the measurement is close enough to some sort of threshold, then it's a no go, and that can kind of stack up all the launches that are behind it. I'm thinking of people trying to get on an escalator, right? And somebody falls, right?
Yeah, I would say weather, that's it's a good point. Weather is our number one reason for scrubs and delays. So no matter how prepared we are, you can't control the weather. So our instrumentation, exactly like you said, Colleen, is on base to ensure that at least we're not scrubbing for the unknowns. The big weather things that we have to worry about, they differ eastern range and western range, eastern spaceport, western spaceport. Over on the eastern side, you have massive storms. So your big risk is something called wet lightning, which is lightning accompanied by rain. So the lightning that you are familiar with, most likely. On the west side, we have upper atmospheric winds. And then, like you said, our field mills are looking for something called dry lightning. So dry lightning is a lightning strike that's unaccompanied by rain. And it happens when you have these big electrically charged clouds, or you have electrically charged air, that's something very conductive, say like a rocket, is flying through rapidly. So it becomes a target, which is bad because depending on the payload and the sensitive electronics on the rocket, it can really mess stuff up. So we do a lot of detection on dry lightning risk. Those weather balloons are looking at our upper atmospheric winds, and we're doing that all the time.
Also, I wanted to ask you if you have anything that you want to leave the audience with. Like, what are your last thoughts here?
Yeah, so I guess to add on a little bit first to our earlier conversation. So I think we talked a little bit about how standardization is going to help with launch throughput. There's some efforts into standardizing in the interfaces so that there's less mission unique analysis and design and procurement involved. I think we also, in order to help accelerate launches, look hard at our infrastructure, and if we have a significant amount of new launches coming, well, like what do we need to do to make sure that our infrastructure here can handle it? Do we have the facilities we need? Do we have the processing space we need in order to accommodate those launches? And then I also think that, I guess, final thoughts that to leave the audience with is just to keep in mind that launch is a lot bigger of an endeavor than you might initially think. There's a lot of people, a lot of disciplines, a lot of organizations that are all working together to make it happen. And we all have the same end goal, to provide reliable, safe access to space.
Johanna, how about you? Any last thoughts you'd like to leave our audience with?
Yeah, I think just like but just like Kim has been talking about, the standardization between the payload and the vehicle, standardization between the vehicle and the spaceport help us as well, but also standardization among the spaceports so that we can share resources and operate. So the National Spaceport Interagency Working Group is a group. It's a fun Google. I won't get into it now, but they're working to develop sort of a network of spaceports that are interoperable that can support each other. And we're looking at bringing both of the Eastern Spaceport and Western Spaceport, the ranges, into that. That standardization will also help our throughput. But I think exactly like Kim said, the biggest thing I could say right now is that I don't know if any one person on the base could really detail all of the intricacies involved in launching a rocket, from the time that someone knocks on our front door and says, I want to do this crazy thing and launch this rocket and land on a barge, to the day of launch when we pull it off, or or we don't. No one can detail all of those intricacies and processes because it's so complex and convoluted. So we rely a ton on the experience of our range operators, our maintenance techs, our contractors. We have people on who've been supporting the range for decades and decades. And they know the ins and outs of all of our instrumentation system like no one else has. So I don't think that we would ever be able to get anything off the ground if it wasn't for the experience of the guys who are supporting the spaceport and making that happen for the past 20, 40 years.
Well, thank you. Yeah, that's great. I think the people behind it, which include you two. So you're doing great work. Thank you very much for supporting and doing what you do and for being on the show.
Thank you for the opportunity.
Thanks, Colleen.
So for our audience, remember this is part of our How Stuff Works sub-series, the Explainer series. We've done Defending in Space, Space Weather, Dark and Quiet Skies, as well as In-Space Servicing, Assembly, and Manufacturing. So be sure to check those out. All of our shows are available wherever you get podcasts, and you can watch the show on YouTube, of course. Follow us on LinkedIn to get notified and engage with our speakers, or you can go to csps.aerospace.org and subscribe to our newsletters. Thank you to James Liggins, our technical director, and thank you to our audience. Until next time.